Welcome all. Welcome everyone. Thank you for coming out tonight. This is a lecture I've been personally waiting for quite a while. I met Carl a few years ago when he was doing research on this now published book and on this project that you will hear about shortly. And at that time, he reminded me I invited him. So I have made good on that promise, and he did not forget. So it's a great pleasure to have Carl-Dag Lige with us tonight. Carl is an architectural historian, a critic, and a curator, and member of the Estonian Society of Art Historians and Curators. He's also a junior researcher at the Faculty of Architecture at the Estonian Academy of Arts. His academic interests focus on the history of modern architecture, particularly the relationship between architecture and structural engineering. In 2018 to 2019, he was a grantee of the Graham Foundation for Advanced Studies in Fine Arts, and in 2020, together with his team, he received the annual Estonian Architecture Award for the exhibition Miracles in Concrete, Structural Engineer August Komendant. He is editor of the now published book, Miracles in Concrete. We have a few copies here for you to see. Structural Engineer August Komendant, published by Berkhauser Verlag and the Estonian Museum of Architecture in 2022. We had a chance to visit with Carl and with Bill Whitaker, head of the archives here, just before this meeting. It was something you unfortunately missed if you were not there. It was quite remarkable to see the drawings firsthand and hear Carl and Bill converse about the drawings. Is really quite wonderful and reminds me of the power of having archives in a school of design. Lastly, I just want to say I took a quick glance at the book before Carl's arrival, and I want to say I was really happy to see that this is not just a monograph on Komendant. It's more about the genius of one individual, but rather the reconsidered history of modern architecture as a collaboration, and in particular between the architect and the engineer. And I suspect we're going to be seeing a lot more of this, and I really want to thank Carl for taking that tact in this publication. So with that, Carl will be speaking on Engineering Modern Architecture, August Komendant's Method of Structural Design. Thank you, Carl.
Thank you, Frank, for having me. It's a great honor to be here at Penn. After 5 years of research and different activities related to the legacy of August Komendant. I want to thank Frank personally and for historic preservation here at Penn. Also the Architectural Archives and Bill Whitaker for his tremendous support throughout those years. I also want to thank the Komendant family, August Komendant's daughter, Melike Komendant Phillips, and George Yuri Komendant. Melike is an architect, Yuri is a structural engineer. They have been following my path and have been helping out with in various ways throughout those years. I'm also grateful to Berkhauser Verlag for organizing the books for tonight's lecture and event. The slides you are going to see today are designed by Mari Eelmaa of Tuumik Studio in Estonia. She is also the designer of the book as well as the exhibition of 2020. I didn't include credits to each image, but majority of the images come from the collections of the Estonian Museum of Architecture, the architectural archives here at Penn, but also private collection of architect Oskar Tenreero, the National Archives of Estonia, and some others. Lastly, I would like to thank my alma mater, Estonian Academy of Arts, where I just started my PhD studies and am working as a junior researcher. So this talk will be about 60-70 minutes. After that, I hope you have questions that we can continue in a discussion format. Even if this topic might be unfamiliar to some of you, but I hope there will be some points which will be of interest to you. Initially, I thought that maybe it should be more like a presentation of an academic paper, but I'm glad I dropped this idea. This lecture will be more like an introduction to the legacy of August Komendant. The lecture will be in 3 parts. In the beginning, I will focus more on Komendant's design thinking or even design philosophy. And we started to think that maybe the title of the talk should have been not August Komendant's method of structural design, but August Komendant's values or even philosophy of structural design. And let's see if I can provide also some critical perspective, not just to speak of a lone genius of Komendant. So some basic data about him. Here he is standing in front of the Habitat 67 apartment building designed by Moshe Safdie for the 1967 Expo in Montreal, Canada. Komendant was the primary structural consultant for that project. He did not only design the structural solution, but was also largely responsible for figuring out the actual construction process of this building. Komendant was an Estonian. He was born into a peasant family, but was educated as a structural engineer in Germany. Finished his studies just before Hitler came to power. He had started his research career at the Faculty of Engineering, but decided after the regime change to come back to his native Estonia. And as an Estonian, I'm really happy that he came back to Estonia because he did for a decade so many interesting projects there, which are not yet internationally known, but I will briefly talk about a few of them in my lecture today. So during the Second World War, together with his family, he escaped Germany. Escaped Estonia first to Germany. After the war, served the U.S. Army there as a consultant, reconstructing the Rhine Valley bridges, but also some buildings outside of Germany related to the U.S. Army. So when the borders opened for war refugees, he decided to move to the US and came here in 1950. And he remained here for the rest of his life. He lived initially on Manhattan, but when he finished his building in New Jersey, Upper Montclair, he moved there with his partner Helmi Aren, and he had a fellow Estonian, an architect called Oswald Mitt, who designed his home. The building still stands, but unfortunately has been changed quite substantially. Komendant in 1978 received, as one of the first structural engineers, the AIA medal for his service to architecture. Throughout his career, Komendant taught first in Tallinn at a technical university, and after coming here to the United States, he primarily taught at Penn, together with Louis Kahn, Robert Le Ricolet, and Norman Rice, the graduate students of architecture here. He published 4 books, but there are a couple of more manuscripts which I had
the privilege to do research on last week. This will be my next step. I'm trying to get deeper into Komendant's design thinking and what I would even call his design theory. Professionally, Komendant was an expert on reinforced concrete structures. He, from his studies onwards till the end of his career, focused only on concrete structures. He didn't work in steel or in timber structures. He was educated at the time by the best German professors. Germany was more theory-oriented in terms of concrete structures at the time. So Franz Tischinger, for example, might be the best known name. He defended his thesis at the time. Komendant was a student at the school in Dresden. Early on, Komendant became interested in pre-stressing technology, which was developed by Eugène Freycinet and Franz Tischinger in France and Germany, respectively. And after the war, Komendant was doing extensive work on precasting technology. Why Komendant is important to me as an architectural historian is that he is among those structural engineers who valued high-quality architecture. He was very motivated to work with highly talented, often poetic architects, like Louis Kahn, for example, with whom he worked on about 15 projects. 7 of them got built. It's a coincidence that they were both originally from Estonia. Louis Kahn left Estonia when he was 4 or 5 years old. Komendant spent a longer time there, and in late 1950s they met here accidentally. But I will come back to that a little later. So Komendant was not just a service provider to architects. He was highly interested in the quality, not only of design, but also the actual construction process and the final quality of what gets built. Sure, he was, like most of engineers, very pragmatic in his approach and emphasized the importance of economy, sustainability in nowadays terms, but also teamwork. Many design tools and methods which are used today were not there back then. Digital technologies took their first steps at the time. Komendant never learned to use computer, even if they were in use from, let's say, 1960s, 70s onwards. Maybe not directly as design tools, but first as calculation equipment, let's say. He did majority of his work using an old school slide rule. There's a story that later in his career he took a small calculator to help, but I'm not sure if that's true or not. So teamwork between different parties involved in the design and construction industry, you could say. Architect Richard Klumb, in an interview a few years ago, told me that Komendant often in design meetings didn't talk much, but he was the one who, in the end of the talk, would briefly gather the different thoughts and put it in a condensed form in a language that was understandable to everybody who was behind the table. So he was kind of trying to stitch together the different positions, be it a client, an engineer, architect, or a contractor. So briefly about my own context, why I am here. When I was still working at the Estonian Museum of Architecture, we started the research project on August Komendant's legacy. It had been on the table, so to say, for a long time, but nobody had taken initiative. And it was such an important topic that I felt that now it's finally the time, and this is when it started. So we had several aims with the project. One of course is his personal legacy and his professional work, which is crossing boundaries, but also to widen the perspective of architectural history. History writing has changed substantially during the last decades, and we have, even if my research is also focused on one man and his legacy, let's say, architecture as a discipline and construction industry and building is substantially a collective effort, and I think rewriting histories, it's important to consider other contributors to the process as well. And structural engineers have had a major role in a lot of interesting buildings which were built in the 20th century, but which are getting built now as well. We also wanted to emphasize the teamwork aspect. We reached out to contemporary engineers and involved them in the exhibition project, gave them guided tours of the exhibition, and many of them came to visit the museum for the first time. So it was a nice way to reach different audiences with this. And sure, to evaluate the quality of architecture and built environment of the very recent history. So the outputs of the project, I would say the first large one was the exhibition. This was presented at the main exhibition hall in Tallinn, the Estonian Museum of Architecture. We were glad to receive an annual architecture award from the Cultural Endowment of Estonia for their core team of the design of the exhibition project, graphic designers and the architects of the exhibition. So it was close to 500 square meters and more than 400 items related to Komendant's career, many of them from the collection here at Penn. On the left-hand side, you see an early structural model for the Richards Medical Laboratory building. This was the first time ever this model traveled not only outside of the US, but outside of Philadelphia. Let's see if it ever travels again. So there were different personal items in addition to design drawings and models and photographs on display. This summer, we finally finished the book. So the same core team, Marje Eelmaa is the graphic designer, together with her partner Martin Eelmaa of Tuumik Studio. Majority of the images are previously unpublished, and this is, as I'm a historian, I don't have a technical background, either in engineering or architecture. So I did not want to cross my expertise, so to say. I tried to involve those who are more competent in the technical side. I had a consulting engineer, a legendary Estonian engineer, Tiit Masso. He read the manuscript, made hundreds of remarks, and now I'm honest. I can say honestly that I am happy to give a book also to structural engineers to read as a history book, not embarrassed of its content. So yeah, just some snapshots. There's a book at the back of the hall you can later browse. And two versions, the Estonian and English version. But enough of that. Komendant and theory. As mentioned, Komendant was a very practically oriented and pragmatic person, though inspired by high-quality architecture. He wrote quite extensively from early on, from 1930s, until late his career in the 1980s. For the first decades, he mainly wrote technical papers for journals and related to his own projects. But from late 1950s, early 60s, he started to more deeply reflect on his design values as a structural designer, and what were the principles he was, or what were the principles that guided him in his work. As might be expected, his body of theory or philosophy, it's not coherent in a professionally philosophical sense, but it's a combination of different ideas which he rephrased and changed throughout the years which followed. But there are some core ideas which remained, even if he rephrased them. So here's a longer quote from Komendant from 1960. This is one of the early articles published by him in Progressive Architecture magazine, which was one of the primary magazines of architecture at the time. I quote, "The basic principle of structural engineering is simplicity. Statically balanced masses and areas arranged in harmony with the overall structural system and its surroundings. Each structural element should clearly indicate its purpose and transmitting those forces and loads to which it is subjected. Each structural system should be appropriate to the material of which it is made. Equally important, construction should be simple and economical." It's like the core of his values, and I will cast a light on different components which are included in this. On the right-hand side, it's a nice caricature made by his daughter Merike. It's a concrete element, a column, a part of the column of the Richards medical labs, and in the background probably the skyline of New York. So in his 1972 book, Contemporary Concrete Structures, the first proper chapter of the book is called Critical Evaluation of Design. There he addresses several concepts of design which combine architecture and engineering. So he kind of tries to build the bridge. So in terms of the creative activity, he emphasizes 4 different phases. First is the image phase, which includes the processing of ideas and concepts, meanings, the weighing of possibilities, and the analysis of meanings. This phase is abstract, free of limitations. This is immeasurable. This is something which is, let's say, more common to architects. The next phase, design phase, it's more practical. It's the realization of the initial image. It's not abstract because it involves practical considerations and limitations. The third phase is construction, the building of reality and the realization of design. As a fourth point, he articulates critical evaluation of the finished product. This is also an immeasurable phase that you can't be quantified. But he also adds that critical evaluation actually has to be involved in all of the three previous phases. So it's a natural part of the design and construction process. He makes a distinction between two strategic approaches to design. The first is artistic, and the other what he calls philosophic approach. Artistic approach makes use of forms and patterns as universal elements. Architecture here is like a research for the right forms for making useful spaces. And Komendant gives his value judgment to this approach in a rather critical manner. He says that artistic approach leads to confusion, aimlessness, and experimentation, like it would be a bad thing. It is highly subjective, based upon feeling, lacks objective principles. I can hear Louis Kahn, Louis Kahn, Louis Kahn. So he's not supporting the artistic approach, but the philosophical approach, or the philosophic approach. Yeah. So in case of the philosophic approach, form is not the primary element of design, but the result of abstract and physical relations, and thus only part of the meaning. Forms and elements have to be combined in a meaningful way. And he says that function provides guidance and objective answers. His use of function as a concept is somewhat abstract. He's not just speaking about the practical function of an individual building, but it's a more philosophical understanding of the purpose of an individual building, for example. So, to the philosophic approach, he gives his judgment in the following: that philosophic approach, using function as the basis for all phases of design, is conclusive and convincing. So how does he explain the philosophic approach on a more practical, maybe it's not actually a practical level, it's still a quite abstract level, but he makes a distinction between different criteria which help to kind of understand and guide the design process. Here's a nice quote from him, also from the same 1972 book. The more conscious the designer is about what constitutes good design, the more successful he can be in pursuing his aim. You could underwrite that also in the contemporary moment, I would say. So, the critical evaluation of design and the primary criteria. The first one is rational solution. Komendant says that a rational solution is something which carries out the purpose of the project and satisfies all conditions with maximum efficiency. It does not interfere with the functions the structure is designed for, and it should correspond with the image of architectural solution, thus be aesthetically acceptable. So basically, you have to follow the architect's idea. It requires structural and mathematical knowledge and the understanding and experience that result in a trained intuition. His understanding of engineers' intuition is quite interesting. This is not something related to poetics, but he talks about intuition as something which is based on knowledge and experience. If an engineer has enough knowledge and experience, he can intuitively find a solution to a project. Now we come to what I'm primarily interested in, the aesthetic quality. Not that many engineers talk about aesthetics, but Komendant thought about it and wrote about aesthetics several times and throughout a couple of decades. So he makes a distinction, a three-part distinction within the quality of aesthetics, or the aesthetic quality. First, he stresses the expressiveness of a structure. According to this principle, the design must exhibit the characteristics that indicate the structure's purpose, function, and performance capacity. The appearance of a structure should express all its embodied qualities and should make the observer aware of what the structure is or is expected to be. Essentials are simplicity, clarity, and modesty. So this is something related to the so-called structural honesty principle, that a building or a structure should kind of speak about how it has been designed, built, constructed. Second, the quality of atmosphere. This, he says, is rather difficult to define, but every building should have an atmosphere that corresponds to its purpose and character. He says that atmosphere is something that makes the difference between a house and a home, for example. Third part of the aesthetic quality, end means relation, is basically the optimal way how to implement expressiveness and atmosphere on a practical level, how to best achieve those previous goals. And the third primary criteria of critical evaluation of design is economy, which relates to effective use of materials, simplicity and efficiency of the structural system. I'm not going to read this quote anymore. It's too abstract already. I should show some images of buildings, right? Maybe just a couple of quotes before we move on to projects. I've tried to gather quotes from different architects and specialists who have expressed their understanding of Komendant's approach to let's say the more creative architectural aesthetic side of built environment. And there's a fascinating Louis Kahn quote from 1968 from one of his lectures at Princeton, where he says, among other things, that, I quote Kahn, his suggestions, he refers to Komendant, when they are referring to the architectural field, are to be disregarded. But when they are purely from an engineering standpoint, they are completely regarded. I'm not sure how often Komendant proposed really architectural ideas. My impression is that that he, let's say, helped Kahn get his projects better to kind of realize the dreams or the image of Kahn's projects. Another architect who recently made a comment about Komendant's approach to architecture is Bob Geddes, who said that I think he was a builder engineer. He produced. He worked with Lou, he worked with me and others, but I don't think he was himself the generator of form, end of quote. Komendant, true, he was very interested in the practical construction process and didn't do architecture himself. Even if early on in the 1930s, I think he designed several buildings on his own where architects were not involved. I'll skip the George Komendant's quote, but but in 1985, Komendant himself, in a rare interview, mentioned something about aesthetics and beauty. There he says, everything has to be there, and it has to be arranged in a way that the result is beautiful and has aesthetic appeal. I don't like to use the word beauty. Ladies have beautiful dresses, but a building has aesthetic appeal. I have always paid very much attention to the aesthetic appeal of the structure. Komendant and concrete. I'm not going to go into technical details here. I will just briefly remark that, as mentioned in the beginning of the lecture, he was a specialist in precasting and pre-stressing technologies. Pre-stressed concrete works on many levels, but on a practical level it helps to save materials and costs, but on an artistic level it helps to create more elegant structures. So in 1952, this was his first published book in the United States, Pre-Stressed Concrete Structures, and this is, by the way, the book with which he reached Louis Kahn. Kahn's engineers knew about the book and decided that they need Komendant's help in one of the new projects Kahn was going to work on. Precasting, when he moved to the US, he designed several concrete plants, not only here but also in Latin American countries. So about 5 or 6 projects. A few examples of his innovative use of concrete would be those. This is one of his first professional projects. It's located in Tartu, Estonia. On the right-hand side, a new hangar for the for aircrafts. It's a repair workshop. So there he used. This is supposedly the first case in Estonian architecture where pre-stressing was used. There are tie rods cast into the floor level here, and the steel bars which go inside the tie rods, they were pre-tensioned with huge wrenches before casting. This is another early example, grain elevator, a grain silo, also in Tartu. Here Komendant proposed the use of so-called sliding formwork, which mechanically helped to lift the formwork so that you didn't have to build the whole structure or the whole form. Some workmen on the construction site. On the left-hand side, the silo as it was just completed in 1941. During the Second World War it was blown up, but part of the silos remained intact and was actually put back in use after the war. It consists of 15 monolithic concrete silos. Here is an experimental design project done together with Franz Tischinger after the war. It was supposed to be a huge dam on the river called Isar in Germany. And Lakewood Pre-Stressing Company was one of the plants he helped to design. This particular one was established by local Estonian businessmen and engineers. He was also a shareholder in this case. Unfortunately, it went bankrupt pretty soon, but it was one of the first precasting plants in the US. Here's the plan of the factory. The layout of the factory, but also the equipment was designed by Komendant. It's the casting bed and it's actually pre-stressed beam, and you can see the hydraulic jacks which were used to stress the steel. There's another unbuilt project done together with Henry Klum of Puerto Rico. He was of German origin, but later moved to Puerto Rico. This is a design for a church which combined precast elements and shotcrete concrete, which is a spray concrete. Here is a group of engineers and contractors in another concrete plant. And this is one of the huge Firendils, so-called Firendil trusses that was cast to build storage in New Jersey, a cold storage. Here you can see the assembly of the building. I would like to draw your attention to two construction workers. One is here, and the other is here. Standing on top of this thin column is a ladder. You can see that they are still learning how to build precast buildings. So here's an experimental project by Komendant himself. It was like a highway, a garage and a helipad, and in one version included also a restaurant. How to combine highway design and architecture. I think he did it as part of one of the classes here at Penn. It was it was like a example to the students. And another example is the case system. It probably refers to Komendant system. It's a modular building system he developed based on his experience on the Habitat 67 and some other projects which used precast modules to build self-supporting boxes. But now, I chose 7 iconic projects by Komendant done together with more or less well-known architects, and I will briefly explain their background and try to bring out Komendant's role or the importance Komendant brought to the project. So here's, I would say, the most important early work from Komendant. It's a stadium grandstand in Tallinn, Kadriorg Stadium, designed by Elmar Loh, who was one of the best modernist architects in Estonia at the time. And here the most remarkable thing is naturally the cantilevering roof of the grandstand. Sure, there were earlier examples by Nervi, by Finnish architects who designed the Helsinki Olympic Stadium, but in a small country like Estonia, which didn't have a large construction industry and competence in that field, it was quite remarkable. This is a post-construction photograph just after it was finished, and it remains as a most important national track and field stadium in Estonia. Rare color slides from 1939 of how the stadium was used. Another contemporary photograph, and this is how the stadium looks today. So Komendant, as a young engineer, he had graduated 3 years before the stadium was designed, helped the architect realize something that other engineers in Estonia at the time would probably not have been possible. Second project, we come to Philadelphia. The first major project Komendant did together with Louis Kahn is the Richards Medical Research Building, close by, just a block. Komendant was reached out by Kahn's engineers to initially design a competition proposal for Enrico Fermi's memorial in Chicago. But it was also at the time Richards was just starting, and Kahn had become interested in precasting and new possibilities of concrete. So Komendant was somebody who could consult him to realize Kahn's visions. This is an early structural solution. The model I mentioned briefly before, on the left-hand side, it's not visible very well, but it's an elevation of one of the laboratory towers. And the Komendant designed the structure to be built of precast elements. Here is the scheme, and it's like building a three-dimensional jigsaw puzzle out of concrete elements. Precasting technology and building out of concrete elements was a very new thing in the US context at the time. There were some earlier studies and implementation cases in Western Europe, but the Komendant was somebody who tried to popularize precasting here in the States. This is Komendant's early design for one of the Firundil trusses. This is the early phase. This is how the final Firundils look like. On the right-hand side, they have arrived on the construction site. Here, the construction has developed further. On the left-hand side, this is the post-tensioning procedure with hydraulic jacks. This is how the floor slabs were prepared, different components put together. The central tower this was built of monolithic concrete, but the laboratory towers were of precast elements. And here, as many of you know, Kahn, together with Komendant, tried to express how the forces are distributed within each individual element, which parts are carrying, where you need more stronger elements and where lighter elements. I really like the photograph on the left-hand side. This is after the completion of the first construction phase, before the so-called biology towers were built. This is like a one-to-one scale section of a building in real life, which clearly kind of exemplifies the principles of expressiveness mentioned before, how a building or a structure speaks about itself. Another Philadelphia project, superbly important in the contemporary moment, with the uncertain future of it. The Philadelphia Police Administration building was one of the few projects Komendant did together with Geddes, Brecker, Qualls and Cunningham. This was among their first projects, and they were also interested in new technologies, new possibilities, and decided to involve Komendant to the process. So here's a street elevation and a schematic, like a schematic office floor plan with reflected ceiling plan. You can see the distribution of individual precast items or elements. This is the structural system. I'm not going into detail here. These are floor elements, and again the post-tensioning procedure. This is the facade panels. These were load-bearing, post-tensioned structural elements. So this is not a curtain wall, but the exterior elements work as an organic part of the whole structure. At one point, there appeared cracks in one part of the structure during construction. Komendant on the left-hand side, talking to Bob Geddes, was called on site, and as Geddes remembers, instantly knew what the problem was. Apparently, the contractor decided not to put some steel rods in places where Komendant had required, just to save the material. But if you skip some relevant materials in critical parts of the structure, then sure, you will have problems. But it didn't cause any substantial problems. Those parts which were problematic, they were redone, and the construction continued. So this is how the building looked after it was completed. Some color slides just a few years after it was completed. These are by George Yuri Komendant, who visited his father's work. So, as many of you probably know, currently there's a huge debate going on about the future of this building. I can just express my personal opinion that it would be a terrible shame if this building was torn down. Sure, we have to acknowledge the injustice that has been done to particular social groups during the past decades of related to police violence. But I would claim that architecture or an individual building is not guilty. People do the mistakes and make bad decisions. There's a good possibility to rethink the future of the site, to involve those local groups that have been suffering the most. But sure, there's the debate. I even wrote a short piece on the community wall, or how you call it. I'm not sure if it changes anything, or what are the key factors the municipality kind of considers when they articulate their final guidelines for the future. But as an example of innovative architecture and engineering, I think it would, in the future, it would be a remarkable site in Philadelphia to kind of illustrate the optimism of the 1960s, how to contribute to society. It was kind of a renewal wave in the city. The Rizzo regime became later and kind of invaded the building and its architecture. But we move on, time passes. We come back to Louis Kahn. Komendant was one of the primary structural consultants to Louis Kahn, also in case of the SALT laboratories, or the SALT Institute for Biological Studies, to be precise, in California. This is the iconic image, as you know. On the left-hand side, an early sketch by Louis Kahn of the site. On the right-hand side, the building completed. This was the early site plan. The meeting house and the housing were not realized, but the laboratories were. This is the initial version where it was divided in 3 buildings. But Komendant was involved in both phases of the project. So this is the early structural solution. It consisted of the so-called box girders and folded plates. The primary task here was to provide those large spans to make the work of the laboratories flexible. This is not very well visible. But this is the final structural solution. Again, Komendant proposed Firendil trusses. So the central span is about 19 meters. And what is interesting here is that those Firendils, they form like separate mechanical floors where all the mechanicals are placed so that the laboratories themselves remain free. Here you can see on the left-hand side preparations for casting concrete, and on the right-hand side the laboratory before it was put into use by scientists. The so-called study towers for researchers, and some color slides from the very final phases of construction. This is how it looked after it was completed. Concrete having a substantial role, not only structurally but also architecturally. If you haven't visited Salk, I would strongly recommend it. I have to admit, this is among my top 3 architectural favorites I've ever been to. From the outside, many would say that, oh, concrete, it's cold, bleak, ugly, whatever. But if you go there, the humane scale, the quality of detailing, the overall atmosphere of the ensemble, not to consider the climate and the top scientists, Nobelists working there, it's just great, it's just great. Now again, briefly about habitat. On the left-hand side, architect Moshe Safdie on the construction site. As a young architect, he was 26 or 27 when the project commenced. Sure, he didn't have the knowledge how to build that. He needed somebody like Komendant to make this reality. These are some early studies. This was meant to be a way larger complex than was actually built. Here on the left-hand side, you can see Safdie's sketch, general layout of the site, a section of how the boxes would come together, and here it says something like model plus photos for Komendant. So just before we came here for the lecture, we saw at the archives probably one of those models that was sent to Komendant. And on the right-hand side is Komendant's drawing, a kind of reply to Safdie's initial proposal. What is interesting here, for example, is that Safdie here dreams how the boxes would be put together. Komendant answers with cranes, tries to figure out how it would be actually possible to build on site already. What's the location and how should be, what's the sequence of the construction. So some early studies. On the right-hand side is a beautiful drawing by David Reinhardt, who used to work for Kahn, but Safdie stole him for the Habitat project. The main kind of idea of Safdie was to create a dense living environment, but what would provide the, let's say, qualities of a suburban living or a private house. You had huge terraces, a lot of sunlight in individual apartments. So every apartment has a garden, some have several. This is a structural solution, I'm not going to dwell on that. Here is Komendant's, basically it's a force distribution scheme. Quite early on, he envisioned or tried to understand how the forces would come to the ground. What is remarkable is that the structure, these boxes, these precast boxes, support themselves, and they are again tied together with post-tensioning cables. There is no additional external or internal structure. This is a typical Komendant drawing. This is for one of the housing modules. This is a great image to explain post-tensioning technology. On the left-hand side is an example of one apartment and the different components, different precast components, which kind of could compile it. On the right-hand side is an explanation of how the post-tensioning cables were put inside the ducts, inside the walls of the precast elements. This is a temporary concrete plant which was built just next to Habitat 67. It was demolished after the building was ready, so the precast elements were produced basically on site. This is the factory production of one of the housing modules. Later they would show to the construction site and the crane put them together. So this is just after completion of the building. It still looks quite futuristic nowadays. Even more than half a century later it was completed. Sure, it's a success and a failure at the same time. It kind of tested the boundaries of what modern architecture can be about. This kind of luxury living, I would say, is not possible for everybody. It became much more expensive than expected. Sure, it was an experimental project, but still. Yes, so I'll move on. Kimball Art Museum, I would claim, is the most important collaboration between Louis Kahn and August Komendant. One of the most exquisite art museums built in the world during the 20th century. And here I would focus on the so-called cycloid shells. Marshall Myers, an architect from Louis Kahn's office, proposed to use this type of geometry. Komendant has said that cycloid geometry, this was the first time it was implemented in real life, and it hadn't been used in architecture before. So these are some of Marshall Myers' geometric studies. This is Marshall Myers' early drawing of how it would be. Actually, wouldn't have functioned like that. But what is remarkable here is his thinking about the use of light, right? The use of natural light, how the shells would reflect the light, natural light. Here's the artwork and the visitor in the gallery. I'm sorry I put the Kahn drawing so small here. It's barely visible. But this is another indication of how an engineer and architect have a dialogue or a conversation. The so-called cycloids, the cycloid shells, they work longitudinally, not in section as typical barrel vaults do. This was Komendant's genius. He tried to figure out how to make them work, again using post-tensioning cables and the geometry, so that they help create and realize Kahn's vision of a gallery which is supposed to be like the best environment for those exquisite artworks which the Kimball collection has. The glass window here, the thickness or thinness of the profile changes. This reflects how this end beam works and how the cycloid transfers the forces. This is one of the key drawings, Komendant's final version of the cycloids. And what is sometimes difficult to explain to people is that how thin the cycloids actually are. Here you can see that. This is not visible in real life, but the shell structure is very thin. Some construction images. Komendant also helped to implement an innovative solution for the floor slab using styrofoam to make the structure lighter and to save from the use of materials. Here you can see these are post-tensioning cables, and this is just before casting. This is, let's say, ordinary reinforcing. And from here, the post-tensioning jacks were connected. It's Louis Kahn on the construction site saying to the photographer, look up, this is where the magic happens. And this is Marshall Myers' photograph made probably a few years after the building was completed. A remarkable result in terms of materials, the atmosphere, the warmth is, I would say, comparable to Salk because of the combination of the light, the concrete surface, but also travertine, and how the different elements, architectural and structural, work together is, again, it's a building which talks about how it was put together, constructed. The front entrance, portico, and the back entrance. And briefly, the final project, which remained unbuilt, unfortunately. In the later part of his career, after Kahn's death, Komendant worked on several occasions with Oscar Tenrero, the Venezuelan architect. He's still alive. He has been also very helpful during our research project, and has made available his archival materials, which he has in Caracas. So from 1980 onwards, together with Komendant, they made a proposal which almost became a project for the new National Gallery in Caracas. It's a national arts museum, a huge building with quite exceptional structural solution. It's somewhat similar, let's say, has a family resemblance to the early version of the Salk structural system. It uses folded plates. This is Tenrero's early drawing, sectional drawing. And he has admitted that Kimball was one of the primary inspirational sources, and he even has a early sectional drawing of the gallery where he drew the profile of the Kimball cycloid. So he says that the proportions basically came from Kimball. Here's a sectional perspective of, I think it's a library space and upper galleries, and a few photographs of the model. There's an interesting story of Kenneth Frampton. Tenrero is good friends with Kenneth Frampton, and he invited Frampton to give a lecture in Caracas in early 1980s, just when the project was beginning, and supposedly Frampton said that you should have a patio. So Tenrero says that this might have been a kind of key moment to think about the interior gardens as part of the museum. So in the final form, there were 4 of them. This is a contemporary rendering of how the museum would have looked like from inside, using natural climate solutions and natural light like in Kimball. So we come to the conclusion of the conclusive part of the lecture. We should ask, what is the legacy of August Komendant as a structural engineer? First, I would say the design philosophy, his approach to the principles of how to design, how to build, how to collaborate to produce high-quality architecture, high-quality environment for all of us. Sure, the built work, which I just introduced, he has got in his project list more than 200 projects. About a third of them were built. Books, 4 books, important books. The most important of them is probably, or the best known, let's say, is his memoirs of his collaboration with Louis Kahn, 18 years with architect Louis Kahn. Here they are together at Penn, possibly in the very same room. Bill Whittaker says yes, right about here. So this is Kahn's studio. The faculty, not the faculty, but the staff. Kahn, Norman Rice, Robert Le Recollet, and Komendant sitting here. I think this is the part of legacy. The fourth relates to teaching. He spent approximately 15 years teaching here at Penn together with Kahn. Later he moved for a couple of years to give lectures at Pratt Institute, and he was a visiting lecturer in several US and international universities. So Komendant felt that teaching is something that is important to him, but also to the general betterment of design and built environment. He taught a lot of architecture students, not only engineering students, but here at Penn primarily architecture students, because he was part of the Kahn studio. When I started my research, it was so difficult to find pictures of Komendant where he would smile. But actually now I've learned that he made a lot of jokes. He liked to be in the center of attention. He was an incredible, he was a very spirited personality. He had very strict views. He didn't like to argue. He liked to be right about things. And when you supposedly when you had counter arguments, he would have stayed silent. But there are stories. There are different stories. Here he's sitting in the living room of Oscar Tenrero. On the right-hand side is Oscar Tenrero's brother, also a well-known architect, Jesus Tenrero. So Komendant visited Tenrero's home several times in his later career. Komendant worked on concrete. Concrete, from today's perspective, is a very problematic material. The huge amount of energy which is used to produce cement, sure, it's still one of the primary construction materials. But I've been thinking that, considering that Komendant was very interested in innovation, he probably would have been dealing with how to find alternatives to cement, or kind of how to find new uses to concrete, if he would have continued to work with concrete. So we can kind of think, what he would have been as what he would have done in a contemporary moment now as a structural engineer. Even if he didn't learn to use computers, he might have liked 3D models and the changed atmosphere of how to how to collaborate, how the collaboration between engineers and architects is happening nowadays. Much more efficient if an architect wants to change something, Komendant wouldn't have needed to do an extra set of drawings. So, with that, I conclude. Thank you very much. And I would be very happy if you had any questions or comments about Komendant. Please. Sorry, it's really difficult to hear. Just speak up a little. Yes. Should I use the mic?
Yeah, you can use this mic.
Okay. So, sorry. Your question, if I got it right, is like how the dialogue happened, right? How the conversation took place. It happened in many formats, I would say. From having drinks at Komendant's balcony with a view over Manhattan skyline to actual design drawings, sending a set of drawings back and forth, making adjustments. To be honest, this is something which is, depending on how well particular projects are documented, it is relatively difficult to trace. Because, for example, in Komendant's case, he said on several occasions that the drawing or even the calculations, the structural calculations, this is just almost like a communication tool. This is the result. He figures out it in his head. And maybe the most critical design decisions were done by a phone call, for example. If an architect explains his or her ambition, then Komendant kind of tries to figure out how to give it a structural form. Sure, they had correspondence, sending different kinds of materials, like bit models, drawings, and they did. Sometimes they were not successful. They couldn't understand each other, be it Louis Kahn or some other architect. Yes, personally, maybe this is something that is lacking in the book. Even if I tried, or in the exhibition in 2020, I tried to kind of visually tell the story of particular projects, but it is really difficult to bring out the actual conversation. We have to interpret quite a lot how particular changes happened. If you don't have chronologically dated drawings, for example, in which sequence the things happened. But it is definitely one of the most interesting parts of design, how space is born, or how a building is actually getting its life, or brought to light and life. Thank you. Any other questions?
presentation. That was wonderful. So when I was looking at it, when you were showing the radial truss and the box giver, I couldn't help but get reminded of the color travel station in New York City. If you go to the station, you definitely see the radial trusses and the box givers. So the question is, did Komendant have any influence on contemporary architects like Calatrava, who marries engineering with architecture? And if you could just speak a little bit more about the impact in architecture.
Thank you. Komendant's influence on architects and engineers. I think his work is best known in the Louis Kahn context, the Kahn's projects, of course Habitat 67 as well, but in terms of particular structural solutions, I'm sure Calatrava is aware of Komendant's work, and there are other engineers and architects who might be aware. Yeah, I haven't taken a more kind of precise look what would be like an exact influence of Komendant. It might be more abstract. Sure, he used. There were other engineers who used somewhat similar solutions, but I would say it needs additional research what the actual influence of Komendant's legacy has been in the decades after his career.
The stadium in Estonia that you showed was, I think, a few years after he graduated from studies in Dresden.
Yes.
What did he do from that point until 1945 when he went back to Germany, presumably for the reconstruction of Europe?
In the late 1930s and early 40s, reinforced concrete was primarily used in industrial buildings. So he designed several industrial buildings in Estonia at the time. There's a phosphorite factory which partly still survives. It was started in 1940. There were, during what we call occupation years, it's from 1940 Estonia was occupied. First from the Soviet side, then the Nazis came for 3 years, then the Soviets came back. And when the Soviets came back for the second time, then Komendant escaped. Nothing much was built during the war years, but he had interesting designs from some reconstruction projects, for example. But I would also say here that this period, let's say especially from 1940 to 44, while he was still in Estonia, needs further research. I haven't found too many projects. I just have them in the list, which I have in the book as well. But some materials might be missing or in places which I haven't been able to locate. But yeah, basically industrial and some public buildings. There was another question.
Thanks for your presentation. This may be in your book, but do you find the record of Komendant's articulation in his own words about why he loved concrete? I mean, it's so evident that it was a material he enjoyed working in, but I was wondering if he had any words on it.
I'm not sure. I'm not sure he ever reflected why he loved concrete. I can just look at it from the perspective of his studies in Dresden. There was a lot of innovation on a scientific level, on theory, in terms of theories related to concrete structures done at the time in Germany. And I think this was inspiring to him. This was something new, that new material, new structural solutions. and he wanted to implement them. And when he became a specialist on concrete, why change track? But sure, he liked concrete. The level of detailing and the things he knew about it, it's even if he was like a practically oriented structural designer, not in a traditional sense, an academic engineer or somebody who just works within an academia. Nevertheless, he was he was both interested in the theoretical level and the practical implementation, to see the possibilities of concrete on every level. But I think the university time, I think, is key to his love of concrete. I've never heard him using the word love, so, but he definitely loved concrete. Thank you. That's one question.
So you mentioned that on designing the projects without the role of an architect or without an architect, right? So would you have more information on those projects, as in how those projects turned out in terms of performance? Maybe working a few years down the line, you realize that architects did not have a role to play in, designing buildings. But then after those projects, he figured out that there is a role that architects play. We have some insights in that.
I would go back to the early projects and say that it was quite common at the time, in the 1930s, for example, that industrial buildings were designed by engineers. It wasn't required that an architect should be involved if you have a very utilitarian building. But I would claim that, for example, in this case, the hangar clearly has architectural features, which Komendant has kind of considered, how to place the windows, where to place the windows. The same is with a grain silo. I mean, the stairway tower is it's like a good example of modernist architecture. It's a very, very clear geometric forms, right? If you look at from a stylistic point of view. But in terms of awareness of architecture as a discipline, as a creative discipline, I would say that probably the key moment was 1956 when he met Louis Kahn, because before that he had, during the Estonian period, sure, he worked together with architects as well, but this change in the late 1950s, where more work from prominent architects started to come in, I think this made Komendant more aware of this side. But I would still say that he wasn't like they sometimes say that every engineer is a frustrated architect. I think Komendant wasn't a frustrated architect, even if he had some individual design ideas. I would claim that he never wanted to be or wanted to become an architect, but wanted to make the work of architects better with his own expertise. Thank you. There were several more.
Can you elaborate or at least comment on what seemed to be his disdain for the artistic and embrace of the philosophical?
You mean elaborate on the differences?
On his embrace, as was described earlier, of the philosophical versus the artistic, if I'm getting that correct.
Yeah. A couple of weeks ago, at the Arts Academy in Tallinn, an architecture professor told me that, Carl, are you aware that quite often what people say or write is not necessarily happening, what they actually do? So the connections might be or might not always be that clear. But in terms of the philosophical approach which Komendant propagated and supported, I would say the key is the more analytical approach, not only to the rationality of the project or economy of the project, but also the aesthetic side, the creative side. My impression is that he understood aesthetics as something which can be almost calculated, or you have to be aware of the importance of aesthetics in design and built environment. But to implement that, he didn't support this kind of poetic approach, but a very analytic approach. That you have to make a distinction, these different aspects of what the aesthetic means, where he included the expressiveness, the atmosphere, and the end means relationship. He admitted this can't be quantified, but you have to consider it consciously. I feel I'm in trouble. I don't have a clear argumentation how to respond to your question. Yeah. Yeah. It's like I can just kind of imagine how he thought about it. He was conscious of the aesthetic side, but you just couldn't take it from the air. He said, I think many times, that you have to. It was in the context of students and their studies that when you start a project or start with a task, you have to feel free as a bird. There are no limits to imagination, but there has to be a point where the idea is brought back from the clouds to the ground, and this is the key moment in terms of structural engineering. So, yeah, I'll finish with that.
I think it's a perfect place to leave it here.
There was an additional question, but
It's getting late, so if you have questions, please join us at the reception. Carl, thank you.